Hi everyone, and welcome to the second of two videos looking at some past exam questions on the topic of group 2 elements. In this first question here, we're saying we've got magnesium and strontium. When it reacts with oxygen, magnesium forms a white powder called magnesium oxide. Write the equation for the reaction of magnesium with oxygen. Okay, so we're going to have our magnesium. It doesn't mention state symbols anywhere here, so we don't need to worry about that. Oxygen, remember, is O2. And then if we're going to make magnesium oxide, we know that magnesium is from group 2, obviously, but if we look at our periodic table, just remind ourselves, oxygen is from group 6. So magnesium is going to make a 2+ ion, oxygen is going to make a 2- ion if it's in group 6, so therefore the 2+ and the 2- will balance out, and magnesium oxide is just MgO. Okay, we want to make sure we get the right formula. And then in terms of balancing it, if I've got 2 oxygens, I need to have a 2 there, and I need to have a 2 there. Magnesium also reacts with dilute acids. Describe what you'd expect to see if magnesium ribbon is added to an excess of hydrochloric acid. So we'd see the magnesium would disappear into solution. Okay, it's an awkward one. Using the word disappear makes it sound a bit like a magic trick. But it's also not really correct to say it dissolves, because it's not dissolved in the water, it's reacted with the acid. So you can get away with disappear, you can get away with dissolve as well. So it doesn't really matter which word you use there. But the magnesium would disappear or dissolve into the solution, and the other thing we'd see is fizzing or effervescence as hydrogen gas is produced. Strontium reacts in a similar way to magnesium. Describe one difference you might observe if strontium instead of magnesium was reacted with acid. Well, it's going to do the same thing, so we're still going to see the strontium disappearing and we're still going to see the fizzing. But what's the difference then? Well, if you look on the periodic table, where is our strontium? So strontium is further down the group than magnesium. Remember, the group 2 elements get more reactive as you go down the group. So we're going to get the same reaction, but we're going to get a faster, more vigorous reaction. It's going to be all the same things happening, but it's going to disappear in solution quicker. We're going to get, more intense fizzing. And that's what I want to do. But make sure it's comparative. So faster, don't say a fast reaction, a faster reaction than if we had magnesium. So you've done that comparison. Here's another question. Student thought fizzing was due to magnesium reacting with water. Write the equation for the reaction of magnesium with water. This is now, if you watch the previous video, this is now the third time we've done the same equation. We've done it with barium, we've done it with calcium, now we're doing it with magnesium. So you must be able to write the equation for group 2 metals reacting with water, because it comes up all the time. This time they do want state symbols, look. So magnesium is a solid, water is a liquid. Remember, group 2 metals reacting with water, you end up making the group 2 hydroxide. Okay, and again, be careful with the formula. That's going to be a solution, and we're going to get hydrogen gas. That's why we get the fizzing. And we need to balance it by having 2 water molecules. Okay, if we carry on with these questions, there are some slightly more unusual ones on this page, although they're hopefully not too tricky. We've got the same one yet again. Barium is reacting with water. Write the equation. We don't need to worry about it. So you can see every time they either say do or do not include the state symbol, so just keep an eye out for that. But this is the same reaction that we've seen over and over again now. But then reaction 2, we've got barium nitride is reacted with water. Okay, so they've told us what barium nitride is, so we don't need to think about that too much. Is reacting with water, forming an alkaline solution. Right, well, it's still going to make barium hydroxide. That's going to be our alkaline solution. And an alkaline gas, what gas is it going to make out of this lot? Well, it's going to make, it's got to involve the nitrogen, hasn't it? What's an alkaline thing that's got nitrogen in it? It's going to be ammonia gas, is what it's looking at here. We didn't need to do the state symbols. So then it's just a case of balancing it. I've got 3 bariums here, so I'm going to have a 3 there. Then I've got 2 nitrogens, so I'm going to need to have 2 ammonias, and I've got six hydroxide ions and 6 hydrogens in total that have come from water. There must be 6 water molecules. So that's a bit more of an unusual one. They do like to give these kind of cryptic hints with it. It's an alkaline gas, and so you do just need to think about some of those things. They're usually things you've heard of, right? They're not some, mystery molecule that you go, I've never seen that before. The mystery product is always like ammonia or water or carbon dioxide or something that you've heard of. Right, here we've got calcium oxide reacts with water and with nitric acid. State the formula of the compound formed when calcium reacts with water. So the formula, not the name. When calcium oxide reacts with water, that's going to make calcium hydroxide. We've seen that over and over again. If calcium oxide reacts with nitric acid, it's going to make calcium nitrate. Okay, and so the nitrate ion is NO3 minus. So again, we're going to have 2 of them in a bracket. It is worth making sure you're familiar with these different ions. The nitrate ion from nitric acid is NO3 minus. Right, final question. Identify a compound of calcium that could be used to convert soil pH from 5.8 to 7.5. So this is kind of similar to the question we saw in the previous video. We could use calcium hydroxide. We could use calcium oxide. Could use calcium carbonate. I'm going to go with calcium hydroxide here. And then here, calcium phosphide is an ionic compound used in rat poison. Okay, can be prepared by reacting calcium metal with phosphorus. Write the equation for that. Okay, so it's calcium. Again, no state symbols here. Phosphorus is telling us it's P4, and we've got to make Ca3P2. So therefore, if I started with P4, I must make 2 of those to get my 4 phosphoruses, and then I've got 6 calciums, haven't I?